Alright, so we're learning about slopes of parallel and perpendicular lines. Remember that parallel lines don't intersect. Be quiet, Max. And that perpendicular lines do intersect at a 90-degree angle. Anyways, the first thing we got is these four equations. And we are trying to tell which of these are parallel, if any are parallel at all. So you can do a few different things. You can graph all four of them. So that seems like it would take a lot of work. So y-intercept, 1, 2, 3. Then we go up 4 over 3, up 4 over 3, okay? And there's the graph of the line that's written in red. Maybe it's not perfect, but my lines aren't going to be. What are you going to do? Then you have blue, y equals 2, so you have a point at 2, and this line extends right and left. Then the green one, first point's at -5, and then you go up 4 over 3. Then you do that again. And you connect those. And my perfect drawings are. And then you have y equals -3. So you have another straight right to left or left to right. So anyways, that's one thing you can do to see which lines are perpendicular or parallel. However, you can also look at the slopes. This one has a slope of 4 over 3, and this one has a slope of 4 over 3. So if they have the same slope, they're parallel. Okay? These ones both have a slope of 0. And since they both have the same slope, they are also parallel. So you can easily look at the slope and tell which ones are parallel. I just made you, go the long route of graphing because that's more fun for me. Okay. So here we have four equations. Again, I'm not going to graph these ones. However, in order to decide which ones are parallel, we have to make sure they're all in y equals mx plus b form, or slope-intercept form. This one here is, and this one here is, which means we have to take the green and the yellow and rewrite those in slope-intercept form, which means we have to solve for y. So we have x plus 2y equals 4. We got to move the x from the left to the right, so we have 2y equals -x plus 4. And then we have to divide each term by 2, which essentially gives us y equals -1/2 x plus 2. Okay? Now, this has a slope of -1/2. This blue equation has a slope of -1/2. So you know the blue and the green are parallel lines. Now we have to do the yellow equation. We have y minus 5 equals 3 times the quantity of x minus 1. We have to do the distributive property first, and we get 3x minus 3. And then we need to move the 5 to the right side, so we get y equals 3x plus 2. So now you know that this red equation has a slope of 3, and this yellow equation has a slope of 3, which means these two are also parallel. You could figure that out as well if you were to graph both of them. This next part is a geometry application, and you have to prove that ABCD is in fact a parallelogram. Okay? Parallelogram is like a rectangle, but it's slanted a little bit. But it's got two sets of parallel sides. So you have to prove that those sides are parallel, because you can't just say they're parallel just because they look, because if the AB and the DC were just a little bit off being straight, they would eventually in the future intersect with each other. So we can say that line AD is parallel, that's the parallel sign, to line BC, because it's obvious that they are both vertical because they're running straight along these blue lines here, okay? So now we need to prove that AB is parallel, so we can say these are vertical. That's the reason for that. Now we can say AB is parallel to DC, and the way we do that is we have to find the slope. So if we find the slope of both of those lines and they are equal, then they're parallel. So we have to take m equals y2 minus y1 over x2 minus x1. Or you can even do the cheating way, which I will do the cheating way, so this lesson isn't as long as it could be. And we rise 2, and we run 1, 2, 3, 5. So our slope of AB, let's erase this junk here, slope of AB equals 2/5. And now we're going to find the slope of DC. Same thing. Here, we rise 2, we run 5. Rise over run is 2/5. So yes, that is a parallelogram because both pairs of opposite sides are in fact parallel, and we prove that. Okay, perpendicular lines. Two non-vertical lines are perpendicular if and only if the product of their slopes is -1. Vertical lines are always perpendicular to horizontal lines. Okay, so here we have 4 different lines. We have x equals -2. We have y equals 1. We have y equals -4x. And we have y plus 2 equals 1/4 times the quantity x plus 1. So, automatically, we can say these are perpendicular, and perpendicular, like that, because x runs up and down, and y runs right to left. Okay? Y, though, we have to figure out by multiplying the slopes and seeing if we get -1. So the first thing we have to do is make sure that we know what the actual slope of the red is. So we're going to put that in slope-intercept form. So we have y plus 2 equals 1/4 x plus 1/4. And we subtract 2 from both sides, which means we get y equals 1/4 x minus 1 3/4. Okay, so we have 1/4 and we have +4, so for our slopes, right? So this, our m equals -4, and for this, our m equals 1/4. So the rule is if your slopes multiply to -1, they are in fact perpendicular. -4, this is saying -4 divided by 1/4, and that equals -1. So we can prove that these two are also perpendicular to each other because we multiplied the slopes and got -1. Well, we have another little geometry application. they want us to prove that PQR is a right triangle. That's the goal here. So what we're going to do is we're going to find the slope of PQ and QR. PQ and QR. So we're just going to take the short route, and we are going to say that we rise 2 and run 3 for PQ. So we have 2 over 3. And for this here, since the line's going negative, we have negative and we rise 3 and run 2. Now to see if those are perpendicular, we have to multiply 2/3 times negative 3/2. One negative is negative, but that is 2 times 3, which is 6, and 3 times 2 is just 6, and that simplifies to -1. So that is a right triangle because angle RQP, this angle right here, is a right angle. And a right triangle contains one right angle. Okay, now we're going to write some equations. So we're going to write an equation in slope-intercept form for the line that passes through 4, 5, and is parallel to the line described by y equals 5x plus 10. Step 1 is to find the slope of the line. Find slope. So we have the equation y equals 5x plus 10, and we have learned that the slope is the coefficient in front of the x, so m equals 5. Pretty easy. So we also know if we're coming up with a parallel line, the slope has to be the same. So our parallel line slope must be 5. Alright? The next thing is to write the equation in point slope form. We learned that back in 4-7, I believe. Right in point slope form. So we're going to take slope form, change my color, y minus y1 equals m times x minus x1. And we're going to use the 0.45 that they gave us in the original for our x1 and our y1. So we have y minus 5 equals slope, which we determined was 5, times x minus x1, which is 4 from up in that set of points above. Okay? Now we write that's all we do for that. Step 3 is we're going to take that equation now and we're going to write it in slope-intercept form. Write in y equals mx plus b. So we're going to take y minus 5 equals 5 times the quantity x minus 4, and we're just going to solve for y. So we have y minus 5 equals 5x minus 20. We're going to move the negative 5 to the right side. These cancel, and we have y equals 5x minus 15. So y equals 5x minus 15 is parallel to the original equation of y equals 5x plus 10. So make sure you have those 3 steps written down, because that is really not a difficult process if you actually write down the 3 steps to use. To when you don't write down the 3 steps and you just have an example and you're like, I have no freaking clue how to get from step 1 to step 3, that we have issues. And since this lesson is also about perpendicular lines, we have to know how to write the equation is slope-intercept form for a line that passes through 3, 2 and is perpendicular to the line described by y equals 3x minus 1. So, step 1, same exact steps as before, honestly. So, step 1, as we said before, find slope. And I'm just going to put find m. So, we have y equals 3x minus 1. The slope is the coefficient, so m equals 3. But remember, when you are finding a perpendicular line, the two slopes have to add up to negative 1. So, what you're going to do is you're going to do the negative reciprocal of the slope. And that's going to be your new slope. So we have 3 over 1, right? Because you can make any fraction into or any number in a fraction by putting over 1. The reciprocal of 3 over 1 is 1/3, and then we just make that negative, because 3 times negative 1/3 is negative 1. So, that is the slope. The second thing is we need to go to point slope form. And remember, point slope form is y minus y1 equals the slope times the quantity x minus x1. And we use our 2 points, 3 and 2 from above. So we have y minus 2 equals negative 1/3 times x minus 3. And then step 3, just like before, is putting it into the form of y equals mx plus b. So we take y minus 2 equals negative 1/3 times the quantity x minus 3, and we do the distributive property, and we get negative 1/3 x plus 1, okay? And then we move 2 to the other side. These cancel, and we get y equals negative 1/3 x plus 3. And notice the Christmas colors I used for you. So y equals negative 1/3 x plus 3 is perpendicular to y equals 3x minus 1. And lucky for you, we are done.